Okay, thank you everyone. I guess it's gonna be in English, right? So, okay. I will quickly talk a little bit about microservices and cloud native. You probably got this, so I will get over. Quickly, who am I? I have started way well long. It's like 25 years ago. Um, Basically went to US just after the towers collapsed. The day they have collapsed, I have purchased tickets to US. Startup on some betting failed, whatever, miserable fail, epic fail. Then I came back, another startup, well, smaller fail. Then another startup that was successful exit, and then I was a bit tired, so I got a job at Monster. I wanted to work for a US company, so that was one of the US companies available here. And later on, I have ended up in IBM. After 6 years with IBM, I was like, I'm too old, so I will try to found one more company, or otherwise I will end up there for life. So I give it a try, and that's when we started Stratox. Noticeable things what we did with Stratox, you have probably heard about Komerční banka, new digital bank, so we did deliver the platform that automates the software delivery over there. The same thing we have done for Partners Bank nowadays, doing for JNT, Raiffeisen, and with Code Now, we have a couple customers like in the US, Personal AI, Zásilkovna, Paketa, Metrans here. So you have maybe heard some of those. What is Code Now? Shameless plug. Cloud native software delivery platform, simplifying multi-cloud / hybrid cloud software development, and our expertise is going on-prem basically, and working with Kubernetes in on-prem environment. Our focus, because we are all ex-developers from corporate environments, is to say, well, we want to make life of corporate developers a little bit less miserable. So what I'm gonna talk about, why microservices, what is what, etc. I will just somehow rush through that. Why to do anything at all? Why to do microservices? So this is some, I believe, Microsoft referential architecture for a bank. I would say it's a business view from a consultant's perspective, how complex organization can look like. If you notice something what is very funny, everything is nice and discrete boxes with no overlaps. Everything actually works fine. So cannot read it, but investment banking, business stakeholders, commercial banking, retail banking, etc. Then you have some risk, horizontal, governance, compliance, horizontal, back office, core processing, etc. So everything works great. Then another view is organizational structure, which more or less fits. And again, everything is nice and discreet, So I have retail banking group over here and taking care of retail customers. But I also have other arms of that company, and they do have different business stakeholders. They have their own budgets and their own priorities, and they hate each other so they don't want to collaborate from principle because they have different set of KPIs and different goals and targets. So that's how it looks like. When you connect these two together, you get this. So essentially, retail banking, that matches this nice vertical, but then you have secured loan origination, and you need CRM. Oh, whoa, not so fast. You need that needs CRM, and CRM has history, and everything is at the end connected to each other, compliance and financial modeling and fraud, different business units and everything. So basically, that's how when this gets developed for a certain period of time, you will end up with implementation that looks like this, basically. It's one big distributed monolith. You can have ESBs in the middle, you can have whatever you want, but essentially everything depends on everything. So it's hard to maintain, and nobody wants to finance it. That's I would say the most common problem that we are seeing is that business stakeholders would like to change something, but they are not willing to finance IT assets of their well, counterparts. And because their business functionality is hidden across the enterprise, without financing the others, they cannot move forward. Well, and that's a showstopper. So then they discuss and they align and they try to find consensus, and that's difficult and it takes ages. Cloud native, I will skip that probably because you know what it is, but yeah, scalable applications, public, private, hybrid cloud. So yeah. What is a bit less understood, I would say, is microservice architecture. So you can speak about domain-driven design, which is a methodology that helps you to define domains that could match, so let's say, business capabilities of that organization. And then within the domains, in the DDD lingo, you have bounded contexts, and they can be implemented as microservices. So that there is some connection to that. Nonetheless, it is even originally, you know, this is a Martin Fowler's quote, you know, from 2007 or something like that. Microservice is built around business capabilities. So when we are talking about API of a microservice, it should provide only use case oriented API that takes commands and produces events in general, hence event driven architecture. If you do anything else, sooner or later you will end up in hell because you are exposing internals of the microservice, maybe in a good intention, nonetheless it will end up as a distributed monolith sooner or later. So how big is microservice? Famous question. So it should do only one thing, and that thing is given by a business boundary. It should be small enough to fit in your head, you know. There is a term for that, cognitive overload, you know, or cognitive overhead. If you cannot understand by reading, you know, and if you don't know what it does, then it's too complicated, you know. So basically, you cannot, if somebody news come in and you are doing handover of whatever you have been working on to another developer, the handover must not take 2 months, you know, that's just way too big. Small enough that you can throw them away. If you cannot actually throw away the microservice because even with microservices, at a certain moment you get to the situation where you say, well, the technical debt accumulated in there is so big, it does not make sense to refactor the code anymore. You know, I will keep the API, that's okay, but internally I will completely rewrite it from scratch. One of the thing is there is no containerless, meaning not a Docker container, but containerless that it does not depend on WebSphere application server or WebLogic or another, you know, provider of containers. Basically, it should be self-operatable. So you can embed something into the microservice, but the microservice does not actually have another dependency that has to be separately configured, you know, because if so, and if the microservice itself is not auto-configured, you will end up again in a situation, so how can I configure one application server that is operating 15 microservices and everyone has a different demands? You will end up in hell. So that's that. Therefore, it should be packaged as single executable. Container is fine, you can hide it inside. And generally, you should perceive microservice as you do when you install just another Unix package. Generally, that's how to think about it. Microservices definitely have different VCS or source code, Git roots, you know. Why? You never know who provides it. You have definitely in a bigger organization different role-based access control settings. Somebody is provided by a third-party vendor, something is internal. It definitely is way more complex than in a startup environment where you have single mono repo and everything inside, you know. That works, but if you take a look how big companies are working with monorepo, they have ton of tooling on top of regular Git. So that's why polyrepo is way more common approach, I would say. How do I design microservice? Exactly, domain-driven design and Conway's law. For those who don't know Conway's law, I maybe have it. I will explain it later. What is Conway's law? But that's a way how to design the microservice, because you do not have to design everything up front. refactoring is part of the game. You need to have a tooling, and that's the role of a lot of DevOps automation that enables very cheap and very fast refactoring. But that's how to find out the boundary. You can have common code libraries. In domain-driven design lingo, it's called shared kernel. So I don't know. We were just discussing. So I don't want to install a big fat DMS, because what is DMS? Well, it is just access to metadata about files and documents which are stored in a folder-like structure in some storage. And whether it's file system, S3 or whatever, well, that's probably not that difficult. And all other aspects of DMS like workflows, and that's a different domain of problems actually. So you can write a DMS as a library and then share it across microservices, and then you have one microservice that provides that, and other microservices can use the same library to create their own replica of those documents in their own local storage. I will speak about automatic provisioning. I will speak about own your state later. I don't know. Microservice definitely always should own its state. Microservice must not depend on a state which is provided by somebody else. We have a term called microlit. So you have a microservices, business logic, distributed in micro packages, and then you have a monolithic database, which is operated by somebody else, and you have no control over that apart of maybe schema. So that's not a good idea. So microservice should own its state. That's important. It should be provisioned automatically. I should be able to declaratively specify what is the deployment target. GitOps, you probably know that. Microservice should be aware of its status. There is a lot of misunderstanding between developers and let's say platform providers, DevOps engineers actually comes, that developers, and somebody has to tell them, you need to make the service to be aware of its own state, because the self-healing capabilities cannot be solely provided from the outside. The microservice should be prepared for that. And where to put. Definitely microservices are not for every place in the organization. Yes, I have seen core banking system nowadays in microservices. You can definitely do that. Nonetheless, there is couple characteristics when microservice is viable, feasible, and makes sense. Frequent changes, definitely. And if you think about, okay, this is going to be frequently changed, therefore what it means that the build and deploy pipeline should not be executed in hours. If I'm frequently changing some code and then I'm waiting, 60 minutes for build and deployment, that's not going to make developers happy. It definitely should be independently deployable. Again, something that we are observing quite a lot, that you can deploy this microservice, but there has to be another 15 microservices already running, otherwise it's useless. Thank you. It should be organized around business capabilities. We spoke about that. Isolated and autonomous. This is the thing. The difference between SOA, traditional service-oriented architecture, and microservices is mainly in the thing that in SOA you were providing function on some endpoint, but how that function actually gets delivered, well, nobody knows. Typically, it was just orchestration of another calls. That's welcome ESB. But microservice, on the other hand, should be able to promise that the unit of work will be delivered. Therefore, if I'm saying create customer, the customer will get created. And not that I will get response 500, cannot create customer because the backend system C is currently down. That's not acceptable answer. And this is something that should be solved by software architects and developers and should never be actually compensated later. Own its state, which means, okay, I am creating customer, or I need to actually read some customer data in order to provide some functionality. First name, last name to send notification, very good. Where it leads? Well, it leads to the situation that I need to start consuming events from CRM, From those events, I will replicate this customer ID, first name, last name. That's all the data I need to know as a microservice to be able to promise that I will deliver notification which actually speaks to the customer with first name, last name. And here comes event-driven architecture. Who will give me the event last name has changed because somebody got married, you know? So I need to know, and it's a different microservice. And I need to have my own replica of the data. Well, that again comes with a price. What if I will lose the replica? And event-driven means eventually consistent. So do all the data between all the data stores needs to be strongly consistent at certain moment? Well, they don't, you know. It's just the fact that somebody has to think about timestamps and provide reliable infrastructure. And suddenly we can speak about guaranteed delivery and how to provide platform that actually guarantees that the event will get delivered. Mobile but addressable, well, where the microservice runs and how do I address it? You know, so again, there were times when I was doing writing a code that client was actually resolving the URL of a target service which I want to call. Welcome UDDI and all these concepts, you know, super cool. But what if infrastructure change? What if the network topology change? What if somebody says, well, we are moving from on-prem to public cloud, and suddenly everything changes, even the DNS changes. And then what? Then I will be, how the services will continue communicating. You definitely don't want to impact application code just because you are changing network topology. All of that lead to this picture. I like that, you know, if you want to go to the carousel, you have to be at least that big, you know. And this is just the beginning. I will skip these. Of course, everything needs to actually, yeah, okay, so quickly. When I want to need new nodes to the, let's say, Kubernetes node pool, it should not take days, you know, it should be quick, you know. I need to monitor everything and I need to provide the monitoring information, because if I do not, you know, how do poor developers know what the hell is going on, you know? Suddenly they are responsible for 10 different deployment units, and how do they find out that something is wrong, and what is the root cause of that wrong? Application deployment and DevOps culture. DevOps culture means I need the collaboration to happen like that. You know, cannot be that me as a developer, I'm writing a code, I need to deploy it somewhere, and suddenly Argo gives me 500, and I'm lost. And I can start Googling, but I don't have the rights anyway. And somebody tells me, ah, sorry, we have a production incident, you know, tomorrow. So that means I can go home, you know. Designing tips, how to design microservices, divide and conquer, definitely modeling the business capabilities and start from the big, you know, and take a look on the organization from the outside, because the only purpose why the microservices are getting made or being delivered is to fulfill the business capabilities. And the business capabilities are there only for the reason because the organization does business. So first I take a look from outside, what kind of business are we actually doing, for whom? That's the only thing. Talking about microservices, how big is, well, modular monolith is a very good pattern. And especially for the teams that have no prior experience in integration problems and versioning problems of microservices at scale, start with monolith. You can always make a cut and just make a separate deployment unit from it if you are using interfaces and you are coding against interfaces, not implementations. That refactoring is very cheap. Conway's law, well, why these actually systems, the big systems fail to support big organizations? Well, it's very simple. Because if you think about it, in past 20 years, it was the thesis was that basically I will buy a BPM software, and the BPM software delivers certain capability, which is modeling processes and executing processes. And then I have a set of people who are experts in how do I actually work with particular BPM product, and I will form a center of expertise around that because those people are productive. And that's how big silos actually gets formed, you know. And then when you need to get something delivered, which is touching business processes, you are ordering a piece of work from the center of excellence. The problem is a wealthier business stakeholder came before you, and then they will tell you, oh, yes, we will do it happily next year. So Conway's law says organizational structure is there. Face the fact, if you're not changing the org chart as part of the digital transformation, you need to cut the business domains into smaller pieces so it better fits the org chart. Because if you will pour enough money for a long time enough, any software architecture or integration architecture will copy the organizational structure. It's inevitable. It always happens. So that's what this clever guy said, well, some time ago. Last responsible moment. Again, when speaking about application developers wants to do something, they typically don't know what they want, you know. Why? Because at the very beginning, when they are thinking, now I would like to do a microservice, they don't know how it will look. Because you don't want to go waterfall. You don't want to spend, you know, half a year thinking about the design. You want to start doing that. I will start, I will code it, I will deploy it. Well, and now I find out it's completely fucked up. So I need to go back, I will refactor, I will make a cut, and I will make 2 of those. And then I will find out, and suddenly the second piece, I should not own it. So Charlie, please take over. And because it's Charlie from different department, I need to put a broker in between us. That's how it actually gets developed in agile fashion. This says, don't try to make complicated design at the very beginning. You will fail anyway. And yeah, this actually comes from domain-driven design. Make implicit explicit. If you think that everybody knows that TNT is an acquired part of our company, and we have acquired it last year. Nowadays, everybody knows. 20 years from now, nobody will remember. How long the code will actually keep running? I don't know. If it is important, make it part of the code. Service choreography over orchestration. Well, from delivery perspective, what it is about, you have 2 types of how to actually make long-running processes happen. Orchestration says there is a central guy which says, you do this, then do that, then do that, then do that. This has a one single nice feature, and that is I can ask about any instance of any long-running business process, single guy, and he will tell me, okay, so onboarding of this customer, that means create a CRM record, generate new documentation, put it to DMS, then open his internet banking, then do this, then do that. Where is instance for this customer? And it is so far. You can ask a single guy. That's orchestration. Single point of querying, very good. Well, single point of failure as well. Each time you change the workflow, you change the orchestrator. Who owns the orchestrator? That's so it comes with a price. Choreography, on the other hand, says, I have done this, here is event what I have done, and I don't care for whom it is important and who wants to do what afterwards. It's very open for extension, very open for change. On the other hand, it's a bit more difficult to ask, okay, so where is the process of the onboarding of this particular customer? Well, that's a tricky question suddenly. Yeah, really. Yeah. Putting it all together, so suddenly why do I do microservices? Well, because I want to actually move the money spending portion under the guy that owns the money, which is a business stakeholder, and therefore create an environment where the money are getting spent, and therefore change is getting implemented, and therefore time to market could be actually improved. That's why I do it, you know. That's why microservices. But then, with each and every microservice, I need to talk about that. You know, versioning. How many microservices do I have? How do I roll back to a previous version? How many versions of the given microservices I keep in a container registry forever to last per major builds? I will throw them away. I don't know. Integration again. So a lot of integration schemas, contracts, etc. So it's a lot of topics that on a platform level should be delivered and fully automated. Because if they are not, you will talk to developers a lot. Because each and every developer will be asking questions about that, most likely with each and every microservice. So imagine an organization when you have 50 developers, they all together own 250 microservices. That's a lot of talking. That's a lot of meetings. Some patterns, domain-driven design. Well, yeah. How are we doing with time? I have no clue. 33 minutes. That was fast. So I don't know. I have so many slides. So, but maybe questions. If you want to know anything about whatever, just ask me. I don't know. Is there anyone? There is no one handling the Slido. Yeah. I don't know how to do it. So just ask. Pavle. Okay, I will continue with some more slides. Slido, máme Slido nějaké otázky? Máme.
Chceš otázky teďka?
Jasně, tak já už mluvím půl hodiny, tak bych mohl mluvit ještě hodinu. Jako. However, dependency on some service registry, console, etc. Eureka microservice should somehow get its configuration, join framework ecosystem. Well, yeah, definitely. Service registry, server-side discovery, stay mobile but addressable. We are more in favor of, let's say, Istio service mesh, for example, or something like that. But yeah, why not? Could definitely be. The question is, who is doing the work? You know, from the code of the microservice, I wanna just say I'm calling party service version 1. Where is party service? None of my business. Somebody else, please solve that. And whether some edge ingress or whatever will solve it using a query to console, why not? Definitely good thing. It's just that I don't know your password. So.
You shouldn't.
etcd, Eureka, yeah. It's configuration stores for microservices could be definitely used. Yeah. And dependency on some service. Yeah, that's so. I hope I have answered the question. Service registry, good. Yes, definitely needed. Just please don't make client to actually ask the service registry, because then you are putting a business logic specific to particular service registry implementation to the application code. When you will want to throw away console and replace it with something else, you will have to rebuild the whole application portfolio for the whole company, which renders the change literally impossible. So that's why server-side discovery, not client-side discovery. Can the concept of microservices be compared with the structure of dark websites? I don't know, Thor. Sorry, I am dark web newbie. It's about the distributed computing, definitely. I think I might have something here. Micro front ends, no. I think I had some other presentation. Yeah, this is most of the enterprise business development actually fits this pattern. I'm not saying everything, but enterprise business development is not so complex at the end of the day. You have a storage, stateful component, stateless component, interacting those two, and then maybe interacting in between each other. But I had something in Ada, Kafka. This one. Yeah. Well, from the distributed architecture perspective, what is every microservice architecture is essentially a distributed architecture. And the question is, who will, to the application developers, explain these 8 fallacies? You cannot fully abstract them on a platform level. Sooner or later, they will leak somehow. As the way how you design the underlying concept of your platform, I can take a look to this picture, for example. So over here, I want to do infrastructure DevOps. I want to automate infrastructure provisioning. And if I will design it in a way that I have 15 completely isolated, separated islands, that are somehow replicated in between each other, I can. But I must not actually expose that complexity to the application developers because their life has to be way easier. They do not understand the infrastructure concepts, they do not speak the infrastructure language, and you will never teach them. And from the business perspective, you don't want Java developer to be 4 hours a day looking into Terraform documentation. That just does not make any sense. So. How to abstract them? Well, basically, again, you need to think about it. So when I was talking about that, when you design a microservice, you think from the business capabilities outside in. So I take a look on what the organization is doing and how it is perceived from the outside. You can do exactly the same when designing a platform. So what are the interaction points towards application developer? They do the software delivery lifecycle. So I can take a look, for example, to this picture. And okay, so in this phase, how does the application developer interacts with me with the fact that I need to provide him all the services and most likely abstract away the complexity. And to be honest, it's difficult. It's so difficult that's why we are doing code now, actually. How to abstract away these complexities, exactly. Because they will not learn. So you need to provide a nice and shiny, coherent API, which is use case oriented, and create abstraction layer that encapsulates the underlying complexity. The fact that in order for me to version the component, I need to do git tag, I need to actually generate suffix, I have a different pattern when doing monorepo, I have a different pattern than when doing git flow, then I need to actually produce the container and store it to the registry, then set some permissions, so that the fact that I do all of these tasks, that has to be hidden behind a single command. Please version this component now. That's how. And therefore, developers, they will rely on a high-level business-driven API, and from the business perspective, the API does not change. I could give you another parallel, maybe. If I will, when designing event-driven architecture, the goal is to talk with business events, because the business rarely changes. It changes with new feature requests, with new products, but it does not change as often as the underlying technology implementation. So if I do not have I don't know, Nomad service registered event, I can name it like that, but then I will throw away Nomad and I will replace it with something else. So do I actually consume still Nomad service registered event if there is no Nomad anymore? Does not make sense. So I will instead think, okay, it's a service registered event, and the Nomad thing is an attribute of that given event. Not in the name, and therefore the event will survive Nomad replacement. And the same way you have to think about how do I provide services to or API to developers. So today is Istio. Tomorrow Istio will die and will be replaced by some other technology, which will essentially provide the still same service, and that is service mesh. What is service mesh about? Well, I want to have a single responsible domain-oriented implementation that takes care of throttling, policing, I don't know, retrying, whatever you name it. If that answers the question. Or další otázku máme nějakou ještě? Nemáme otázky? Okay, so 45 minutes. It's just.
We have one more question. So, how to mock service with EDA? What is the minimum domain size and what can be tested together?
Okay. I think I have some. So there is a hidden thing, you know. What is a domain? That's not so simple answer. It's the architect that says what the domain is. You have multiple layers of architects. You have enterprise architects thinking about the overall organization. Then you have solution architects that do actually think about complex systems that are typically spanning multiple delivery teams or multiple delivery organizations. And then you have application architects. So let's say the solution architect, in coordination with the enterprise architect, they have to make a conclusion what is a domain. Over here, I can make a domain based on shape. So all the circles are single domain. I can make a domain based on color. So I don't know. For example, this example is from BBC. Let me show you over here. So yeah. So BBC has some verticals. What they do, but in every vertical they have a search. And in these two verticals they have articles, and over here are some topics. So should I create a domain of topics, or should I create a domain of children? Okay, and then do I have a value stream which implements the single domain horizontally or vertically? At the end of the day, you will find out in a typically big organization that it will be mixture. You know, the domains can be overlapping. You know, the inner implementations must not be overlapping. So over here, they came up to conclusion, let's create a horizontally oriented domains on the theme. And that domain is owned with a single team, and that team is delivering microservices. So I forgot what was the question.
The question was how to mock services with EDA. What is the minimum domain size? What can be tested together?
So minimum domain size, there is no minimum domain size, I would say. How to mock it? Let me show you another thing over here. So essentially, over here I have some events. That's in Czech, unfortunately. So every event has a well-defined schema. That schema should be in some registry. So I can have I don't know, API Curio, and I will do a JSON schema or something like that. And therefore I can, number one, and I should do packed tests. So during the CI pipeline execution, I can do basically contract testing. Number one, then I can avoid a lot of mocking, because if the contract test actually is fulfilled, why to mock anything? It's just way more complicated way of validating. But if I need to actually do the end-to-end integration with mocks, I would question the need for that, maybe. Then there is definitely a lot of producers, or you can write your own mock. So you will say, okay, I need to learn how to actually write to Kafka, you know, this object, you know, serialized using this serializator, and you just create the API command API which says, kick me in, and I will spit out event, you know, and you need to write external integration test orchestrator then, if that is the thing. So you describe the end-to-end test, and the end-to-end test specification being executed by something. exactly knows when to kick to this mock generator, and that mock generator will produce event. But it's just, I would say, try to think about pact testing first, or contract testing. Okay? So, 50 minutes gone, 47. Thank you.